Okay. So we have a question about for the final project for this class. I mean, none of this should be a surprise. The final project. One. Yeah, so just as far as the final project, you're going to host a SQL database on a server. The server is going to be something that you are quote unquote renting from a company that has computers. AWS is a big one. That's Amazon. Amazon Web Services, which maybe some of you guys would know more than me, actually, because you're in the business school. I believe that at this point, Amazon's like main money maker is AWS, and like Amazon, the shopping thing is not really a big money maker. In fact, it's something that they might be able to undercut prices on because of how much they're getting from their AWS. Amazon Ad Services. Okay. Yeah. I don't know. I wish that they'd put a little bit more funding into Alexa because that thing's awful. Like, okay, that's another story. So there's different cloud services. AWS is one of them. Microsoft Azure is another. I think Google, it's just called Google, maybe just Google Cloud. The point would be to have a server where like processing speed isn't so important. It's more about storage size. How much storage size do you need is dependent on how much data that you have. Oh, hold on. So you have to host a cloud. We'll get to the data in a minute. Okay. So that's basically it for the final project. You can go ahead and start now if you like. You can look at AWS versus Azure versus Google Cloud. Maybe you prefer one or another. Uh, what I can say is that for each of them, you run the risk of potentially having to pay some money. It wouldn't be a lot, but it would be maybe $15, $20, $30, something like this. Um, but that is a rare case, but in any case, it kind of can happen. Um, Microsoft Azure, if you're a student and you haven't used it, every year that you're a student, you can get a $100 credit to spend on any of their services that you like. There's differences in, for some reason, Microsoft Azure is very cheap with something called T-SQL. I forget what the T stands for, but that's very cheap on Microsoft Azure, like very cheap. But then if you want to run like MySQL or PostgreSQL, these are very expensive on Microsoft Azure. Not sure why. They're all SQL, but the grammar is a little different. And in this class, I'm not requiring students to use a specific cloud service. That's up to you. I'll probably go through either whichever of these are the most popular among students. And when I'm teaching SQL, I will be using the sort of grammar, if you will, from this textbook that I could grab and wave. Database Management Systems, this book. So there's different flavors of SQL, like T-SQL, MySQL, PostgreSQL, and more beyond this. I think that these are three of the bigger ones. Which one does the book use? Closer to this. Closer to MySQL. If you know one, it's easy enough to shift over to others. All of the queries and all of that's the same. It's just the way that you kind of phrase things might be different. Like if you put quotes around something or not, or if you surround things in brackets or not, and this kind of thing. In this class, also, I'm not going to be going over all of the different flavors and the differences in syntax. I'm just going to be going over the one, and I don't care which of these flavors you use, whichever is convenient for you, I guess. PostgreSQL is nice because it's very popular as far as what's actually being used in the world. Postgres is a little more popular. MySQL is also popular, but it's a little bit more dated and doesn't have quite the same functionality as PostgreSQL does. T-SQL is just something that I actually became aware of because Microsoft Azure likes it. I'm not sure why. Yeah. Okay. Oh, yes. And as far as where to get data from, now populating a database is pretty easy. You write, you know, create table, blah, blah, like 5, 6 lines of SQL, and that's it. That one command will populate an entire table. The difficult part is getting your data beforehand, kind of nice and clean and orderly, such that it can just sort of be vacuumed up uh, into the database. Where to get data? Some students in the past have spent more time on this part, on getting the data and kind of cleaning it up, and then they just sort of threw it in a database and made it accessible. So the quantity of their data wasn't very much, but it was a data set that they wanted to put together. And this was another, people were working as a group because it took a while to get data from different sources, combine it, and clean it up, and this kind of stuff. Okay, so let's see where to get data. Kaggle is great. Kaggle is a place where they have lots and lots of different kinds of data sets. These can be, image data sets and data sets on, statistics of the Titanic and the people who perished and survived there. And yeah, just lots of different kinds of data. Now, here, the data set sizes would be, I would say, on the order of 1 MB to maybe 10 GB, maybe on the high end. Yeah, something like that. So not super big data sets. Yeah, but that would be one place to look. Other places, university websites. I mean, like if there's data that you find interesting, that is the best to get. Kaggle is one place to look. Places, yeah, a lot of university websites will have data. Or even you just Google these things, yeah, you'll find a lot. Okay. I'll try to come up with a more comprehensive list, but I wanna move on. Okay, so we are talking about relational algebra, and the last class, I we went over in detail how to write this query, and this is all wrong. Okay. So the uh, the last class we went over this query where given these relations that we wanted to find people who frequent only those restaurants where there is at least one thing that they like to eat on the menu and they frequent no other places. Um, the query ended up looking like, I'll just copy it. Okay. Oh, the scale of that is like way different. Okay. 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 I want to pick on a student and just have them explain this query here. This one. Why is the query like this? Let me pick on, how about Zaid? Zaid Siddiqui? Do you have a mic? Okay, how about Sunmin? Or Sunmin? Sunmin. You have a mic? Oh, this isn't good. Okay, how about Serena?
Yes.
Hey, how are you?
Good.
Um, okay, how are you following things so far?
Pretty all right.
Okay. Um, do you think you can explain what this query is doing and why it's written this way, or at least what it's doing?
Um, so I think is that the row notation, like the symbol before serves.
Yes. Yes.
Um, so is that selecting um food, I guess food from the serves table. And then it's combining that with I guess it would have to be food from the eats table, right? Um, and then it would populate name and restaurant from whatever was returned from the operation inside the parentheses. And then it would take the name category from the frequents table, and then I guess subtract it from what was returned from taking the name in the restaurants from the multiplication inside the parentheses.
Yeah. Yeah. Um, uh, yeah. Yeah. That's basically what's going on. I have a question though, like this part here. Um, oh no, that's that's really loud on my end. I'm sorry. Okay. Oh, jeez. Right. So yes, what is this part doing? Just the part that I've highlighted in orange.
So that's where I've been a little bit lost. I don't entirely remember what the row symbol does.
Oh, the row starts with an R, and that's why it's chosen for the rename operation. So that just renames the title of a column.
Okay. So I guess then on the inside it would rename in the service column foods to foods two, and then um it would combine that, I guess, with the eats column
With the
and
eats table.
with the eats, yeah, sorry, the eats table, sorry about that. And then rename foods to foods two.
Right. So in like human language, what is this like what is this table? It's taking the eats table, this one, and the serves table, and it's cross multiplying them, right? So it's combining these two together. The this row thing here isn't doing much interesting. What that's doing is it's taking this in the serves table, and it's just renaming this column to be named this column instead. Um, that's all that row is doing. But yeah, then these are cross multiplied, and selecting when foods in here, from this food column, match foods here in this column. Like when those are equal here, then we want to keep them. If, like here, they're not equal, then we don't want to keep them. Make sense?
Yes. So it would only take into account the fries which don't exist and then the yogurt. So basically yogurt would only repopulate, right?
Uh, right. So what, I mean, what is the cross multiplication doing here? Or like, what is it, what does it mean when you cross multiply things? Like, what does that do?
Um,
If I take these tables here and I cross multiply them like this, um, what do I get?
I guess would you have that's where I'm unsure because there's only two columns that I guess have commonalities. So that's where
Okay. So don't worry about the commonalities right now. Just do the cross multiplication or the cross product. What does that do? So I have this table here, eats, and then I have this table serves, and I'm cross multiplying them. So what table do I get as a result?
would you get a table with all five of the columns?
Sure. Yeah. Okay. Nope, that's wrong. Okay. And
So then I I guess it would have John, Amy, and Jane for names, and then food would stay the same. And then the restaurant, I guess, would populate at McDonald's as McDonald's for the yogurt entries for John and Amy. Um,
uh, uh, do you know what uh like the like pairings are? The cross product finds all possible pairings, like all the pairs of things. So, for example,
okay. So would
taking
it,
this row and then pairing it with this row
got it.
and that row, and then taking this row. Oh, sorry about that. Then taking this row and pairing it, and then this row and pairing it, and then this row and pairing it. So that's cross multiplication is just coming up with all of the different pairs.
Okay. Yeah, sorry about that. So then it would, I guess, produce um 8 entries with all the different combinations.
Excellent. Okay, you wanna read out what
Yeah,
those are? I'll try to keep
yeah,
up with you.
yeah, yeah, no problem. So then it would be John yogurt, McDonald's fries, $2. Then John yogurt, McDonald's yogurt 150. And then Amy salad, McDonald's fries, $2. And then Amy salad, McDonald's yogurt 150. Then Amy yogurt, McDonald's fries, $2. Amy yogurt, McDonald's yogurt 150. Jane salad, McDonald's fries, $2. And then Jane salad, McDonald's yogurt 150.
Great. So that's this. John, you McDee's fries. John, you got McDee's. Two fries, great. And I'll do these pairings really quick. Amy salad McD fries, $2. Amy, McD yogurt, 150. Okay, blah blah blah. And each of these will have pairings that I'm not going to write. With the last one being Jane salad and McDonald's yogurt fries, 150. Okay, great. So now we have this sort of intermediate relation, right, where we're combining the table eats and the table serves. From this table, we're selecting those entries, that is to say that we're keeping those entries where the entry in this food column is the same as the entry in the other food column. Okay? Make sense? I'm talking about this part. Yeah.
So then, the John yogurt for 150, the second entry that you have would
Mhm.
match. And then the Amy yogurt, which would be more down below, would also match it. And I think those might be the only matches where food equals food too.
Very good. Okay. Let's see. Yogurt, and wait, I'm sorry. Let's see. John yogurt, and Amy yogurt. Yes, good. Great. So all of the other ones are going to go away. And so if I get rid of these, then what is for, what are these two? These two that remain. So we have this one, Amy yogurt, McDonald's yogurt 150, and then we also have John yogurt, McDonald's yogurt 150.
So I guess that's what I was referring to earlier with the matching. Like those are the only like matches between those are the only commonalities between the two tables, if that makes sense. Where like there's an overlap in data.
Exactly. Yep. Yeah. So it's finding an overlap in data. Here, it's where the food that people eat, or that these people eat, is the same food that is served at this restaurant. So, for example, Amy is salad. We know of a person who eats salad, but we don't know of a restaurant that serves it. So the only things that we can talk about are those who we know their names and what they eat, and then we also know of restaurants that serve what they eat, and yeah, where their equal is restaurants that serve things that people eat. So that is in quote unquote human language. This part here is returning okay. So that's all that this part is doing. It returns the names of the people the names of the restaurants and the foods that are on the menus that these people like to eat. Let's see, who is still here? Did this student leave? That's strange. Okay. Um, well, how about Jeffrey? Do you have a mic? Okay. Can you explain the rest of this query? Your mic doesn't sound very good. Um, right. So I can't really hear you. It's just very scratchy. It's okay. I'll maybe come back. How about Jonathan?
How you doing, Professor?
Doing well. Um, yes. Can you just explain the rest of this query?
Yeah,
Well,
so you have the frequents table, which shows the restaurants that people frequent, and if you do a set difference between frequents and the cross product of the eats and serves, you get basically people who frequent at least restaurants serving nothing to eat, because those are the people that do eat at restaurants. Um, that foods that are served at the restaurant. So when you subtract, do a set difference from the frequents table, you're finding people who frequent at least restaurants serving nothing they eat. Correct?
at least, yeah, yeah. That they've frequent at least one restaurant that serves nothing that
Nothing
they
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 eat.
like to
Yeah.
eat. Yeah.
And then you have the projection of just the name of the restaurant, or is it people? No, I mean the people.
Mhm.
So you project the name after that, um, and then you have another set difference from the persons table. You have a list of all the people, and you find the
Mhm.
set difference between the resulting part of the query
Mhm.
of, and then that's basically returns all the what's called what you want, which is the names of people who frequent only restaurants serving at least one of the foods that they eat.
Oh, no, no, no. Say that last part again. The finding the names of all people who frequent only restaurants serving at least one food that they eat. Um, yeah, only is a very important word here. It's carrying a lot of weight. Um, so why this sort of roundabout thing? Why all these like set differences?
Um, I'm not sure if there's like a more direct way to do it.
Okay. Um, yeah. Yeah, me neither. I don't think that there is. But this is anyway. It's yeah, more of a subtle point, I think. Okay. Okay, great. I want to get to another related query um, that, let's see this. Okay. So this is going to be division in quotes because it's not really division. Well, we'll talk about it. So let's see. So the idea is um, okay. So the idea is to try to mimic this type of fact. If you have A times B and then you divide by B, then you should get just A. Um, but this is for sets, and so uh, uh, things work a little differently. Let me write an example. I'll make two tables. Here's table T1 and table T2. And T1 is going to have entries A and B. T2 is going to have entries B. And let's say here we have 1, 1, 1, 2, 3, 1, 4. Okay. Very good. So, this is the so-called set division. And first of all, I want to just see if you guys can guess, or if you can figure out what the result should be here. That is here. What values go inside of that? I see one guess. 1, 2, and 4. How about others? 1, 1, 4. 2, and 3. Okay. Very good. Lots of guesses. Uh, none of them right, but good job. Good job guessing. Let me go through. I can eliminate some of them for the same reason. Not the first one. This one. 114. If I put one, oh, God. 114. I can't do this because in this table there's only one column, which is A, which would mean that A also has to be a key, and every row of this of any relation should be unique. Here, the number 1 appears twice. So one of those ones would not be allowed to be there. So if, like, this would be okay, 1-4, as far as the syntax. I mean, like, there's everything's unique. But if I tried to put in another 1 or another 4, doesn't work because there's already a 1 or a 4. So that's why this one doesn't work. 1 repeats. So similarly for those, the others, okay. The answer here is just the number 1. What this is, okay. So again, the idea is to mimic this behavior, right? You have something that is sort of like A times B. It has both of them, and then you're subtracting the ones with B, and you want to have just the A's left over. So that is for these values here, A, B. There's some entries that will have connections. For each A, there's a connection with B. And then because certain entries in A have a connection to all of the B's, then when you take the B's out, you keep only the A's that had a connection to all of the B's, not just some of them. So here, in this table, P1, P4, those are the values of B, that everything, that every A that we're keeping is has to have. So here we have 1 with P1, and here we have 1 with P4. So that is why 1 can go here, okay? Because the number 1, A, matches with both P1 and P4, both of them. The number 2, yes, it does match with P1, but there's no P4 connection. So it's not included. 3 is connected to neither P1 or P4, and P4, or I'm sorry, 4 is connected with P4, but it's lacking a connection with P1. Missing. And then here, this one is missing. Yeah, only 1 has both connections. P1 to P1 and P4. Okay. Questions about the concept of this anyway? Like if I gave you another table T1 and another table T2, you could figure this out. Again, okay, if the concept is clear to you, that is this idea of set division. We're given 2 relations. In this example, a relation T1 and T2. I want a relation where the entries that are there have a connection to every entry in T2. Or every column, whatever. Okay. So I want to give you 3 minutes to write the relational algebra query for this. So T1 divided by okay. I'll give you 3 minutes to work on this. And actually work on it. Try to figure out what this query is. That's the most important part. Okay. I see a question here about the missing part again. Why do 2p1 and 4p4 not work? So the key here is that the value in A has to have an entry corresponding to this value of B for all values of B. So in table T2, there's two values for B, P1 and P4. Anything in A, well, only those things in A that have an entry corresponding to both P1 and P4 are allowed in. They have to have, I don't know, all of the IDs, not just one of them. Here they have to have both P1 and P4. So with what is it, 2p1, there's nothing wrong with 2p1. The problem is that there's a missing entry here that's missing. 2p4 is missing. Maybe I should write that in red. So the value 2 is missing a connection, namely a connection with P4. There's this value P4, that the value 2, it does have a connection with P1, but it does not have a connection with P4. So it's missing an ID, it's not included. I have to have everything. Similarly, for here, there is no 4p1. Therefore, 4 is not included in the results. Okay. Did anybody get a relational algebra expression for this? How about Shriyash? No? Okay. Well, sure. We're running out of time. So here, let's do this. Yes, Raymond, please do. Okay. Let's see. So this is what Raymond wrote. This doesn't quite work. So what this will do is it will find when there's at least one connection. When there's at least one. So for example, this would include 2 in the results because 2 does match with P1 here. So that 2 would be included as a result in this, but it should not be because again, it's missing this hypothetical thing that should be there. I've written here for you the actual query that can realize this. I'll let you ponder over it, I guess, over the weekend. It's already 3 o'clock. I don't want to keep you after. But you'll notice that it's a very similar format to the previous query that we had, where you're doing these set differences things. So that's sort of your hint to, as you're making sense of this, you're starting off with a population of everybody, and from that population you're going to remove some undesirables. What these undesirables mean, try to see if you can come up with a way of phrasing it that makes sense. And yeah, what's sort of going on here with this cross multiplication and that set difference. It's similar to the previous one, but not exactly the same. Again, the reason why it looks so much different is, or the reason why this type of format doesn't work is because this would match things that have at least one connection, but we want ones that have all connections. And it's this all that might give you a hint that the format's going to look more like this. Okay, so that's it. Thank you guys, and have a good weekend, and good luck on your homework. I'll see you.
Professor?